I've got a submission here from ringo42 who has got a troubleshoot for us where the copter was flying okay and then it just tumbled to the ground. Blackbox shows that the right front motor turned off. Let's take a look. Here we are at the appropriate point in the log, and we can see that I've got the motor's traces up, and we can in fact see that motor number 2, the right front motor, does just go well. So you say the motor turned off. So first of all, the motor should never turn off while the copter is armed. So the motor I see here has gone to idle, but it should still be spinning. So let's just take a quick look at what your min throttle is. Is 1150. That should be enough to keep most motors spinning. I would be surprised if it wasn't. So when you say the motor turned off, I'm going to assume you don't mean that the motor stopped spinning, but that you mean that you were looking at Blackbox and the motor went idle. If the motor actually stopped spinning, then if a min throttle of 1150 is not enough to keep it going, I would go back to basics and calibrate the ESCs. You can look on my YouTube channel and you can see I've got a video I just put up about calibrating ESCs with bale heli. If you had an ESC that was miscalibrated, it could cause a problem like this. Let's zoom out real quick. Yeah, that's not the first time this happened. We've got lots of stretches here where that right front motor is, or pretty much the entire flight, the right front motor is lower than the others. Lots of cases where the right front motor goes down to idle, but doesn't quite stop because it's jumping all over the place. Here it started idling out. Here it started idling out, and then it idles, and then the copter just can't take it anymore and it crashes. So, yeah, something's going on with your right front motor. You're welcome. One of the things I checked was I did look through the whole copter to see if the failsafe phase changed or if RX signal received or RX flight channels valid changed. That's a good check anytime you've got a copter that drops out of the sky. It's not really, a failsafe event wouldn't cause one motor to be like this, but it's just worth something I always check, even in a case like this, you know, just to cover my bases. But yeah, something's up with your right front motor. Your right front motor is making more thrust than the other three. The other three seem reasonably balanced, but the right front one is always lower than the other three. So my first guess would be an ESC that is out of calibration. The other thing I would say to you is that if you have calibrated, so I think you should follow the steps in my ESC calibration video. Set min command to 1000, max throttle to 2000, calibrate the ESCs, and then go to your motors tab and figure out what min throttle should be. It probably does not need to be as high as 1150, although you never know. But figure out what it should actually be using the motors tab. But I would just make sure that your ESCs are all calibrated. That's the first thing I would check here. Oftentimes, if you have a motor that's failing, or a prop that's loose, or a bad bearing, or something like that, you will find that that motor is running higher than the other three because it's making less thrust. It's kind of hard to think of what would cause this motor to be making more thrust than the other three, resulting in its signal being lower because, of course, the flight controller is trying to balance everything out. I don't know, but we definitely can see, if we zoom out here, we can see that the right front motor, it slowly gets, whatever's happening, it's happening progressively. It's slowly, the flight controller is turning it down and down, and there's this surging that's happening. And notice that the surge here, look at this surge here, that is not, the other three motors are not doing that. So something's going on with this right front motor. It surges here. The power, that means the power from the motor dropped. Then the flight controller had to turn it up to get more power out of it. And now it came back online a little more. And now it's kind of back with the others. And then here it drops out, and it surges, and it drops out, and it surges. What this means is that it is making more power during these scenarios where the flight controller is trying to turn it down, and it's making less power, or less thrust is the right thing to say. It's making less thrust during these scenarios where the flight controller is trying to turn it up. More power, less power. More power, less power. So that could be consistent. And look at the periodicity here. So you had a mechanical failure. There's no question here that you had some kind of a mechanical failure. Also notice that we start to see some periodicity in the other three motors as this one starts doing its weird thing where it's making too much power. Interesting. This one is making too much power, so it gets turned down. These guys are making not enough power, so they get turned up. So the flight controller is trying to balance the motors, and it's moving them to the opposite ends of the spectrum. And I think you could see a definite periodicity, a regularness here in the surging that then results in the copter finally crashes. So the copter did not just suddenly drop out of the air. I know that's what it seemed like from the pilot's perspective, but we can actually look at and this is really cool. We can look at the black box and we can see the problem developing. In fact, if we go back to your earlier logs, let's go back to one of your earlier logs and see what we see. Oh, come on, let there be something. Here, the blue motor, the right front motor is still, oh, here's an example of it. Oh, here it is right here. It's already happening 3 flights ago. But notice that the right front motor is kind of in sync with the left front motor, right? It's kind of not too far off. Now it's a little but moving towards the bottom. And here we can definitely see whatever the problem was, it was some kind of a mechanical problem, I think. Because, you know, like imagine you've got like a loose nut, right? And the nut is tight and it starts to vibrate and it gets looser. If you were to look at that and then finally it's looser and looser and looser and looser and it, boom, it just flies off, right? That would create a kind of a periodic regular readout in like a gyro or something. And that feels like what we're seeing here. Some mechanical problem that slowly exacerbated itself until it died. So, look, what I would do is I would examine that motor and that ESC for some kind of a problem. The chances are slim that it's the other 3 motors that have a problem all at once, and that this motor is the one that's doing something wrong. If I had to pick another motor, it would be the motor that's at the other extreme. The red motor. So maybe look at the back left motor, because maybe what you've got is a scenario where the back left motor, let's say that the back left motor had a loose prop, okay? And so it was not making as much power. So then, when the back left motor has to be spooled up, would that cause the front right motor to spool down? I'm just fishing for any other explanation I can think of here. It feels like if that were the problem, it feels like the motor that's the odd man out is the one who has the problem, and the other 3 motors are all trying to accommodate that and compensate for that. So I really think the front right motor is the one we got to look at. So look, the simplest thing to do is to swap that motor with any of the other 3 motors. Just swap it. Take this one and swap it with this one, the yellow one, the back left. Just swap them. And if that doesn't, and see if now the yellow back left one starts doing this thing in your black box. And if not, then swap the ESCs, which is a little more of a hassle because you got to desolder them from the PDB. But that's the next step, trial and error, right? Swap the ESCs. I think that you'll find if you move this front right motor that the problem will switch to wherever that is. Or if you have a spare motor, just swap that one out for a brand new spare and see if the problem resolves itself. Thank you for your submission. I do like these kind of troubleshooting things, and I especially like it when we get a very clear black box that makes clear something that wasn't obvious from just looking at the flight. It really shows the value of black box and the value of this type of analysis. So thank you for your submission, and hope you get this problem solved soon so you can get back to happy flying.